I'm going to do a couple problems here for your amusement. I hope you enjoy it. Let me first start off by doing the following. Hope you remember these type of problems. Suppose I had to take 27 divided by 8. What we did a long time ago was ask myself, how many times is 8 going to 27? And I would say 3 times. Then I go 3 times 8 is 24, and I would subtract, like in long division, 27 minus 24 is 3, and that was my remainder. Oops. Right. And of course, what all this meant was that 27 equals 8 times 3, and with a remainder of 3. Okay. Now, I want to use this to talk about periods. And I want to start with a simple example. Suppose I had cosine of 15 pi, and I had to evaluate that. Well, I could see that immediately that at 15 pi I'm going in circles quite a number of times. And the trick is to figure out how many circles am I going? Am I turning around? So here's what I'm going to do. First of all, I'm going to state what the period of cosine is, and the period of cosine is 2 pi. So we're going to play this little game. Okay, and then really what I want to get to in a minute is a fraction. Really, the whole purpose is a fraction, but I want to start with a problem that doesn't include a fraction so it doesn't get too confusing. So I have equal 15 pi, and then I'm going to put here the 2 pi, and then I ask myself the following question. How many times does 2 go into 15? And of course the answer is 7. 7 times. So now, having mentioned that, I can subtract the 2. So 15 pi minus 14 pi is equal to pi. And how does that help me? And now I can write the following. Cosine of 15 pi is equivalent to cosine of the following. I'll look at 14 pi plus pi. And of course, I know that this is just a multiple of 2 pi, so it really is going to be equal to cosine of pi, and cosine of pi is -1. Okay, so now I'm going to try another question right now. Tangent of 21 pi over 4. And this was example 1 of your video notes. But I want to show you how I'm thinking of it. Again, like before, what I want to do is establish the period. And the period for tangent is pi. The next thing I'm going to do is write this angle that's in radians. And since I know the period is pi, I'm going to use that as my subtraction. So what I'll write is pi here. But I'll also write it using the denominator of 4. So the key here is this denominator. And the reason I even want to do this video is due to the fact that this is a fraction. You saw with a cosine, this wasn't a big deal, but with fractions, I know this is going to be more of a challenge. So I want a common denominator of 4. So I'm going to put a 4 here, but of course I cannot just put a 4 here because I needed to. I need to counteract it by putting a 4 on top. So 4 over 4 is 1. 1 times pi is pi. So really I've changed the look, but not the meaning. Great. So now here's what I have done. By making the denominators equal, I can just concentrate on the numerators. So just like before, I'm going to ask myself the following question. How many times does 4 go into 21? Notice, because pi is the same for both, I'm ignoring this. I'm ignoring the denominator. So how many times is 4 going to 21? The answer is 5 times. So 4 goes into 21 5 times evenly. So what I have now is 21 pi divided by 4 minus 20 pi divided by 4. So to make this work, notice what I had to do. I had to, if it's a fraction, and that's why I again wanted to make this video, is to first make sure I concentrate on this denominator and make it happen on this other side. So I'll have to match the denominators. Once I've done that, I can subtract and I get pi over 4. Okay, that's my difference. So again, what I'm saying is 21 pi over 4 is equal to what? I just add these two together. It's the 20 pi over 4 plus pi over 4. So, and of course, the 20 pi over 4 is just pi. After all I've done here is gone in circle many times. I have pi 5 times, but since that's the period, well, as far as calculating the tangent of that angle, it's not going to do anything. So now I can get back to my original task, which was finding the tangent of this angle, 21 pi divided by 4. Well, that's equivalent to, and again, I'm going to write this whole thing out, tangent of 20 pi over 4 plus pi over 4. I know that this might come off screen here, that's why I'm trying to tighten it up. But that's equal to, I can ignore this because this is just going period after period after period. It's not doing anything. What I want to really concentrate on is the remainder. Really, all this is about is the remainder. Just like when I subtracted, what I cared about was about the remainder. The remainder is all we care about. So now I ask myself, what's the tangent of pi over 4? And I can go through the whole process, but in this case it's a 45-degree angle. I know it's a tangent. The sine and the cosine are exactly the same, so the answer here is 1. So again, as you consider these questions, these equivalent expressions, what we're finding it is the remainder once we remove multiple instances of this period. So the period is what we care about. We find how many periods are in there or how many times we're using that period and remove it, and then we're left with a remainder.